All right, let's jump straight back into our explainer on physical and chemical diagnostics. Last time, you'll remember we covered a pretty critical lesson. Transformer oil degrades chemically way before those physical windings show any actual damage. Today, we're taking the next step. We're going to focus on how to transition from viewing your data as just a one-off snapshot to actually taking action based on a trend. So, just as a really quick recap of part 1, keep in mind that interfacial tension, or IFT, moves before acidity does. And honestly, this is exactly why you have to compare your data against a long-term trend of successive samples. You really can't just rely on a single snapshot reading. Which brings us to what is basically our golden rule here. Never judge oil condition from a single snapshot test. Why? Well, because a single perfectly acceptable reading can easily mask a rapid rate of change. You might look at today's numbers, think everything is totally fine, and completely miss the cliff your equipment is about to drive off. When we only take one snapshot, we lose the entire context of the fluid's history and where it's heading. Let's actually map this out over a transformer service life. Say you have a declining IFD trend hitting in year 3. Now, your acidity might still look perfectly acceptable, but that IFD drop is actually a leading indicator. It's your earliest chemical signal of oxidation, basically screaming at you that an oil reclamation needs to be planned soon, way before the acidity actually spikes up in year 5. By plotting these data points chronologically, all that invisible degradation suddenly becomes entirely visible. And I love this because it brilliantly illustrates our core philosophy. Just like a doctor looks at your lab work, oil testing is, functionally, a blood test for the transformer. By drawing a single fluid sample, you are getting a direct reflection of the internal condition of that unit. You're catching those hidden problems before any physical symptoms ever appear. It's literally proactive medicine for your electrical grid. To push that medical analogy just a step further, think of acidity rising in your transformer oil exactly like cholesterol rising in a human patient, right? There's no immediate catastrophic crisis today, but it steadily damages the surrounding system, like the paper insulation, over many, many years. Left unchecked, that gradual silent buildup is exactly what eventually leads to a catastrophic system failure. Let's look at a real-world case study to see how this actually builds. We have a 20-year-old transformer, and in this specific scenario, an acceptable acidity level completely hid a steadily declining IFT across 3 separate sampling intervals. The IFT dropped from a really healthy 32 all the way down to 22 millinewtons per meter. Now, a single snapshot would have just told the engineers, hey, acidity is fine, nothing to see here. But the trend was a massive red flag warning that oxidation was actively accelerating. And here is the kicker. Because the engineers acted on this downward trend well before acidity or moisture flagged a critical problem, their proactive reclamation program was a huge success. That single proactive decision bought the transformer an estimated decade of extra life, 10 whole years, literally just from watching the trend lines closely and trusting the chemical data over the physical symptoms. All right, time for a quick interactive check. Based on this exact scenario we just walked through, do you wait for acidity to rise and confirm the issue, or do you act immediately on the IFT trend? Take a second to think about what your play would be. You act on the trend. Absolutely. If you said that, spot on. This proves you can successfully interpret an oil test report and deploy preventative maintenance just like a diagnostic doctor. The absolute chinks, rather than sitting around waiting for obvious damage to force your hand. But, what if the internal stress is already happening? Next time, we're going one level deeper into the fluid to examine the dissolved gases. Dissolved gas analysis, or DGA, reveals exactly what underlying faults are actively happening inside the tank. Whether we're talking thermal faults in the oil or cellulose, partial discharge, or even arcing. Using gas chromatography machines, which separate and quantify those chemical components, will actually read the chemical fingerprint of internal stress. It detects these developing internal faults without even having to take the transformer out of service. So here's a thought to leave you with today. What hidden emergencies is your next sample going to reveal before they have a chance to turn into catastrophic failures? Join me next time as we find out.